We're going to take a look at solving equations the lazy man's or the smart man's way, which is via your calculator. In the beginning of your algebra career, your algebra teacher did not want to tell you about this because it kind of makes you wonder why you learned all the other equation solving skills. There's going to be two ways that are going to be helpful for you during AP Calculus. The first way is using the X Intercept, and we're going to use this contrived and hopefully a little bit clunky looking equation. We want to solve for x. Could you do this by algebra steps? Maybe, probably. I don't know. Looks like it might be a little bit goopy. But if you're going to solve looking for the X intercept, you do have to do some algebra moves in the beginning to set the entire equation equal to 0. Ta-da, we have it set equal to 0. And from there, once it's set equal to 0, we can find the x-intercept on the calculator. These are the steps you're going to use, and I'm going to go through that on the calculator here. Okay, you can see that this equation is in my y equals screen. I'm going to activate it, and now I'm going to follow these steps. I'm going to go to second, calc or trace, and I'm going to choose 0. They're going to give me a graph of my activated equation, and essentially I want to know what is that x-intercept. Once I know that x-intercept, I know the answer to this equation. So I estimate just by eyeballs that that looks to be around 2. So now it's asking me for my left bound. My left bound is give me a number that's left of that intersection point. I'm confident that the number 1 is left of that intersection point. And now it asks me for a right bound. I'm confident that that x-intercept is, well, I can choose a number over here, so I'm going to choose 3. And by the way, if I didn't do this by typing in numbers, I could move my little turtle that you saw in there left and right with these arrows. And now the calculator says, hey, do you want me to take a guess? Well, sure, why not? And now I'm going to get my answer. The answer is x equals 1.751. And you may or may not know, in AP Calculus, all your answers have to be rounded to 3 decimals and accurate to 3 decimals, meaning on the AP test, if you answered 1.75, they would say you're wrong. If you said, just for some reason, well, that's 1.752, you're wrong. It has to be accurate to 3 decimals. All right, short and sweet with that one. We moved on to the second technique, which is using the intersection point instead of the x-intercept. And I've made another contrived and hopefully scary looking equation. We want to solve for x. So now instead of using our algebra skills to rearrange this thing so that it's set equal to 0, I'm going to leave it as is and say, hey, this is a curve, I'm going to graph it. This is a curve, I'm going to graph it. I'm going to see where they intersect. So second, calc or trace and intersect. And when I graph this thing, I get a dud. What the heck's going on here? I don't see my graph. Well, this is a common experience because generally speaking, you operate in the fake world of -10 to 10 for your x-axis, -10 to +10 for your y-axis. And these two equations, they do intersect, but it's somewhere else outside of this window. So normally when this happens, it's a contextual problem, and you would have some reason from the context of the problem to arrange a window a certain way. In this case, you don't have that, so you just have to have an idea of where these might intersect. If you have no idea where they intersect, then you just have to start randomly expanding this window till you find out. So I've already done that. I'm going to pause this and adjust my window. Okay, so now I'm going to go on my x-axis from 0 to 20. And I'm going to do those little slashes every 5 units. My y-axis, I'm going to go from 0 to 50, and I'm going to do a slash every 10 units. That just gives me perspective. And remember that you may or may not really have an idea of where these intersect, these two equations intersect right now, but in a contextual problem, you probably would. All right, so now, well, let's just do this. Let's go second, calc trace, and choose 5 for intersect. And now I see my first graph and I see my second graph and I see where they intersect. And based on my slashes, I could have an estimate of where they intersect, but I'm going to use the turtle now in this case. It says first curve. I usually move that to the left of the intersection point. And then it says second curve. I'm going to just make sure that's to the right of the intersection point. So I've trapped the intersection point between the two turtles. Do I want to guess? Yeah, most of my math life I've been guessing. And now I would have it. The focus probably isn't so great. The calculator says 8.4098401. You could save that as your answer, but if you were going to use 3 decimals like the AP says, you would now have to do some rounding. That 9 makes that a 1. So this is the AP rounded answer that you would need to have. It's okay to go more than 3 decimals, but you can't go fewer than 3 decimals. You'd have to be accurate to the 3rd decimal if you intend to round. All right, those are your 2 methods for solving equations. They will show up throughout your calculus career and beyond. See ya.